Hello, I am Rutuja. I am currently pursuing my studies in Electronics and Telecommunication Engineering at PICsimlab. I have done my online internship on embedded system provided by the Emertxe Information Technologies. I have learned about the introduction of an embedded system and its component and the software used in these projects, and mainly the PIC microcontroller, which is the PIC16F877E. We can implement this project by using the embedded C and the peripheral descriptions, like we are using digital keypads, buzzers, CLCD, and finally I will show you the project demonstration and sample output. So let's go into the brief introduction about this project. So first, the goal of the project is to produce a real world washing operation in the virtual environment by simulation using a PICsimlab. In this project, we have built a simple washing machine prototype using a PIC16F877E microcontroller. This project explains about the washing machine. So we know washing machines are used in the daily purpose in our homes. So whenever we are washing the clothes by hand, so it will take more time and human energy. So for the purpose, we are implementing an automatic washing machine. Nowadays, customers wants to have a fully automated machines instead of a semi-automated. So from the photo, we can see that the microcontroller here displays the status of the machine, and there is another microcontroller which is used for the buttons and turning the dials, and there is another microcontroller in this embedded system for the speed of the motor controller. Embedded system, which means it is same as a computer hardware but is very small in a size, which can be run independently and can work with the large system also. For example, calculator, and it consumes low power consumptions. For example, calculator, washing machine, drones, tracking devices, and also in real-time examples such as military, television, then entertainment purposes, etc. Types of let us see the types of the embedded system. So embedded system is classified or divided on the basis of the requirements of functionalities and performance and ability of a microcontroller. First, embedded system dependent upon the functionalities and performance are real-time embedded system, which means this embedded system provide output in a defined interval only. This system provides a quick response in a critical situation, which gives the most priority to time-based task, That's why real-time embedded systems are used in the defense sector. These real-time embedded systems are divided into two systems. One is the soft and another is the hard. Soft means it does not really follows the deadlines. It will result that the system doesn't give the result in the defined time. Still, the result or output is accepted. The another is the hard. Another is the hard. One is the soft, another is the hard real-time system. In this system, what happens is that the deadline of the task is strictly followed. That means the task must be completed in that specific time only. For example, the real-time example can be a traffic control system, then the military uses in the defense sector and medical uses in the health sector also. Then another is the stand-alone system, which means that this system can work independently, that does not depend on any other host. It can take inputs and outputs. It can take input in digital and or analog form and provides the output. For example, MP3 players and calculators also. These are the examples of standalone embedded systems. Then mobile embedded system. Mobile embedded systems are small and easy to use and require less resources. For example, mobile phones or a digital camera. Network embedded systems are connected to network which may be wireless or wired to provide output to the attached device. For example, home security system or ATM machine and card swipe machine are the examples of network embedded system. So let us move to the embedded systems based on the ability of a microcontroller. First is the small scale embedded system. It is are designed using an 8-bit or 16-bit microcontroller. They can be powered by a battery, the processor which uses the less or the small resources of memory and processing speed. Then on other hand, medium embedded systems are designed using 16 bits or 32-bit microcontroller. These medium embedded systems are faster than the small embedded systems. Then integration of hardware and software is complex in this system. Then third last is the sophisticated embedded system. These embedded systems are designed using a multiple 32-bit or 64-bit microcontroller. These systems are developed to perform large-scale complex functions. These systems have high hardware and software complexities. Because of this, we use both hardware and software components to design a final system or a hardware product. Now we will see the components of the embedded system. So first is the microprocessor or microcontroller. This is the central processing. This is the central processing unit of the embedded system, which is responsible for executing the instructions and controlling the operation of entire system. Then another is the memory, which requires various types of memory to store program instructions, data and temporary variables. Then memory includes RAM and ROM, input and output interfaces. These interfaces enable communication between the embedded system and the external environment. Common examples include digital and analog input-output pins such as serial communications interfaces such as UART, SPI or maybe I2C, etc. Sensors and actuators. Sensors are used to detect the physical quantities such as the temperature, pressure or light, etc. Actuators on the other hand are used to control the physical processes or devices based on the inputs from the sensors. Example include temperature sensors or accelerometers, motors and relays. Sensors, actuators. Okay. Now another component of the embedded system can also be the real-time clock, which helps to keep the track of a time even when the system is powered off. This is essential for the application require scheduling and time stamping or time-based applications. So the software used in this project are the MPLab IDE, Emertxe compiler and the PICsimlab. MPLab is a free software. It's a free software which is used for the development of embedded applications on the PIC and DS-PIC microcontroller, and it is developed by the microchip technology. While Emertxe compiler is a powerful optimizing compiler that converts the ISO code into a high assembly language. Then the PICsimlab is a real emulator of a development boards with MPLab IDE. Now we will see PIC16F8778 microcontroller. As we are using PIC16F877A to build this project. Why this microcontroller only? Because it has a 14-bit instruction words, providing a good balance between the complexity and the simplicity. The architecture of this microcontroller has a variety of registers, making it versatile. Then another point is 8 KB of a flash memory, and flash memory of this microcontroller is reprogrammable which allows for the easy updates and modifications to the firmware. Then it incorporates analog to digital converter with the multiple channels, enabling it to interface with the analog sensors and signals. Then this microcontroller uses the low power features, allowing it to operate efficiently in the battery powered or energy concise application. Then this microcontroller has three timers, that is a timer 0, timer 2 and timer 3. Timer timer 0, timer 1 and timer 2. For our project we have used the timer 2, and it operates on the frequency of 20 megahertz. Embedded C. Embedded C is used to program a wide range of microcontroller and microprocessor, because it is a processor independent, that is, it is not specific to any microcontroller or system. It can work on the various hardware configuration, and it also doesn't require same set of hardware to run a program, and it is a platform independent, whereas the applications written in C are not. Hence the concept of write once compile anywhere came. Another very much advantageous point is that it provides us the portability. Portability of a language is mainly important when an application program must be moved to the other operating systems. Code developed in the C is more portable and user can compile it on the other platforms. With a least specification. C code is efficient and easy to understand, and mainly it is easy to maintain and debug. Then C provides us with the memory management, that is, it provides direct memory control without sacrificing the benefits of high level languages. We can directly access the memory using the pointers and perform various operations using them. It provides us to bit manipulation. As we know, C is a more flexible structured language that provides low level bitwise data manipulation using the bitwise operator. It also provides us with the better performance than any other languages, because C code gets compiled into raw binary executable, which can directly be loaded into the memory and executed. C provides optimized machine instructions for the given input, which increases the performance for the embedded system. So we are going to see the components used for our project. First is the CLCD, which is a character liquid crystal display. Then it is also, here we have used 16 into 4 CLCD, which means that 16 are the columns and 4 are the rows. Therefore this LCD contains total 64 characters. Then the CLCD is a type of a flat panel display technology used in the devices like televisions, computer monitors, smartphones and calculators. Then it operates on the principle of emission by a liquid crystal. Another component we have used is the tactile switch. It is one of the widely used switch that completes an electrical circuit typically. When a pressure is applied to device by the user, which then gives the user a click or a bump in a response, indicating that current is flowing. Current flows, it turns off when the switch is released. The switch are used in a microcontroller for inputs to control the operation of a device and interacting of users. Then what is an interrupt? Third is the interrupts we have used in the project. But what is an interrupt? Interrupt is basically a signals that tells the microcontroller to stop what it is doing and executes a special function called an interrupt service routine. Interrupts can be triggered by various sources such as buttons, sensors or serial communications. So there are two interrupt sources, internal and external, while interrupts are classified into maskable and non-maskable. Timers, so basically we know that we have used the timer 2 in this project. but PIC16F877A has 3 different timers, 0, 1 and 2. We can use these timers for various important purposes. So far we have used delay procedure to implement some delay in the program, that was counting up to a specific value before the program could continue. Timer 2 has a 2 count registers, that is TMR2 and PR2. The size of each register is 8 bit, in which we can write numbers from 0 to 255. The TMR2 register is readable and writable. PR2 is readable and writable register, and it is initialized to FFH upon reset. We have set the PR2 equal to 250 in our code. So these are the sample outputs of our project. We will see its project demonstration. First we will clean and build the project. See here, PR2 is equal to 250. Initially we have set the timer on at initial value it is off. Okay, so we have built successfully. Okay, so this is the PICsimlab. So first we have to set the board, select the board, that is PICgenius. The microcontroller is 877A. Okay, so as you can see, these are all the switches, 1 2 3 4 5 6, like this, and this is the reset button. This is the buzzer which will turn on when we will see that. Okay, so we have set the frequency to 20 megahertz, and we are using 16:4 LCD. Okay, let us first upload the code. Hex file code. Okay, now as you can see, this says that press key 5 for powering on the washing machine. This is the 1 2 3 4 5. Okay, we have to select it only once. So powering on, for turning on washing machine, which will lead us to washing program for selecting the type of clothes. For traversing, we need to press switch 4 once. Like when we select this, it will go heavy, delicate whites. Again when I select this switch 4, it will say delicate white and stain wash. If you want to select let us go with whites. For selecting, we have to long press the switch 4. Yeah, next it will provide us with the water level requirement, that is auto, medium, low. And for seeing more options, again we have to press switch 4 once. Okay, low, high, max, auto. Okay, let us go with medium. For selecting medium, again we have to long press switch 4. Now for starting the washing machine, for washing the clothes, it says switch 5 for starting and switch 6 for stop. Okay, we have to select only once. See, this is the time required for washing the clothes. See, you can see that fan is on when we start the machine. For stopping this timer, we can choose pause. Again, for starting, what happened? Yes, now it's starting. So buzzer will turn on after 1 minute. Until then, you will see a part of a code. So our code first was for the switching on, that is first what we have seen on the LCD. Then for washing program, we shows the types of clothes. Then water level displays for showing the requirement of a water level, that is auto, max and everything. Set time is a method which we have used to set a time for particular clothes and its water level. Then run program is used for the start and stop buttons, that is switch 5 and switch 6. A door status check, we will see this program. A door status check is for the if the fan is off, it will show if the door is open, it will stop the fan and it will on the buzzer, and when the door is closed, it will run the it will start the washing machine and turns off the buzzers. This is all what includes in the door status check. This again here it shows the temperature, that is 27.50 Celsius, and okay. So at last it shows that remove the clothes, which means that clothes are washed. Okay. Last see, we have seen these press key, washing program, switch, water levels, then this is for the time required and the function key. Okay, so conclusion states that this study offers insights into washing machine operation, control system design and simulation methods. At last, thank you for providing me with this opportunity. Thank you, Emertxe.